Hello. Welcome back to the channel. So let's do one more question on area between two or more curves. And in this video, we'll also cover some important points about breakpoints when you have breakpoints in your area consideration, area calculation, and how to calculate the area of the shaded region when you have breakpoints in these type of questions. So now in this question, you have to calculate the area of the region between y equals 4 plus pi sine x, which is this graph. You know the sine function, right? It's like this. So this is your 4 plus pi sine x, and 4 plus 2 pi minus 2x is your line, which is this one. So again, in order to solve these type of questions, in this question you are already given the graph of this function, but you won't generally get the graph of this function, right? So that is why you'll have to first sketch the intersection points. You'll have to first calculate the intersection points in both of these cases by equating their y or x values. So by equating their y values, you'll get the x intersection points, and then you'll sketch the graph for both of these functions. And based on your intersection points, you'll identify the area bounded between both of these curves in this case. But now, since in this question you're already given the graph of the sketch of both of these functions, it's easier to calculate the area of the shaded region here. But in this question, you'll realize that we also have a breakpoint for which our y values for the sine function are greater than the line on the left hand side, and for the right hand side, the y values on the line are greater than our sine function values, right? So that's an important point which we'll have to consider for the area calculation while taking vertical strips in this case, because we are already given our curves in the form of y equals f of x. When we're given y in terms of x, it's better to take vertical strips instead of horizontal strips, right? So that is why if we'll take vertical strips in this case, we'll have to consider the y values of sine function being greater than the line function over here, and over here the values of the line function, the y values of the line function being greater than the values of the sine function over here. So that is why we'll have to break our interval into two parts, which will constitute one part in which the sine function has greater values, greater y values, and the other part where the line function has greater values. So now in order to do that, we'll have to first calculate this breakpoint in this case. You can clearly see in this case that this is your x equals pi in this case. So that is why while calculating the area, we'll have to break one interval as pi by 2 to pi and the other interval as pi to 3 pi by 2 in this case. So now we know everything about the breakpoints and the area calculation using breakpoints. Now let's identify the area using vertical strips in this case. So I'll take one vertical strip over here. This is our arbitrary vertical strip over here, and over here the same as this case. I'll represent it with a different color so that it's easier to differentiate. So now for the white vertical strip over here, you see that your y value, your upper y value is based on the sine function, and your lower y value is based on the line function in this case, right? So the area bounded by the first part in this case would be, first we'll take the sine function, the upper y value is our sine function value, which is 4 plus pi sine x, and we'll subtract it with the y value of the line function, right? So y value is 4 plus 2 pi minus 2x minus 4 plus 2 pi minus 2x in this case, and this would be our height of the white strip over here, right? Again, a basic overview. So in this vertical strip calculation, in this height of the vertical strip calculation, our sine value is greater than our line function value. So this upper y value would be based on our sine function value, and this lower y value would be based on a line function value. So that is why in order to calculate the height of a vertical strip, it is 4 plus pi sine x minus, which is our upper y value, minus 4 plus 2 pi minus 2x, which is our lower y value in this case. So we have the first height, and this vertical strip calculation is based from x equals pi by 2 in this case over here to pi in this case, which is our breakpoint. So this is from x equals pi by 2 to pi. And now let's represent the height of our red vertical strip over here, which is over here. So since in this case it's opposite, our upper y value is based on the line function value and the lower y value is based on the sine function value. So in this case, the height of our the red vertical strip would be 4 plus 2 pi minus 2x, which is our upper y value based on the line function, minus 4 plus pi sine x, which is our lower y value based on the sine function. So, and this is applicable from x equals pi to 3 pi by 2, right? From x equals pi to x equals 3 pi by 2 in this case. So now, when considering the total area, it would be area, which we can represent as A. The total area of the shaded region would be integral x equals pi by 2 to x equals pi of 4 plus pi sine x minus 4 plus 2 pi minus 2x in this case, plus our integral x equals pi to x equals 3 pi by 2 for 4 plus 2 pi minus 2x minus 4 plus pi sine x, and every time we have the width of a vertical strip is dx, so this would be dx, and over here this would be dx as well, right? And I hope it's understandable at this point of time. If you still have any questions, feel free to comment down in the comment section below. So now if we simplify our area over here, the area would be pi by 2 to pi 4 plus pi sine x minus 4 minus 2 pi plus 2x, this would be dx, plus pi to 3 pi by 2 4 plus 2 pi minus 2x minus 4 minus pi sine x dx in this case. And further simplifying it down, we would get pi by 2 to pi, we can cancel this 4 and this 4, so it would be pi sine x minus 2 pi plus 2x dx, plus pi to 3 pi by 2, this 4 will cancel out, 2 pi minus 2x minus pi sine x and dx in this case. And this would be your final answer based on considering every important concept about the breakpoint in this case. So that is why in these type of questions, when you have breakpoints, you always have to consider splitting your whole interval based on the breakpoints, and then calculating the area using vertical or horizontal strips based on how your breakpoints change the height or width of your vertical or horizontal strips, and which was already visible in this case as well, because in the first half of the interval we had our sine function y value to be greater than the line function y value, and in the other half it was opposite in this case. So that is why we had to break our whole interval, which was from pi by 2 to 3 pi by 2, into two equal parts because of the breakpoint x equals pi, and then calculate the area of one portion separately by taking separate height for a vertical strip, and same for the other half by taking a separate height for our other vertical strip in this case, based on the changes to the height of a vertical strips caused by the breakpoint in this case. So that's it for this video. I hope you found this video interesting. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.